lab will be the chemical reactions lab. So there's going to be a series of videos through several different types of reactions. So what we're starting with today is going to be the reaction between copper and sulfur. You do this reaction between copper and sulfur in the chemical formulas lab. We're not going to do that reaction right now. I already did that reaction this morning, and I have my copper sulfide here in my crucible. So we're going to use this and go through this reaction of copper and sulfur. This video will also include redox reactions, and then later on there will be a video for metathesis reactions. We'll do all of those inside the hood. I have all my chemicals over here. I have some distilled water and spatulas. Should have everything I need to do all these reactions. So we're going to get started. So you want to follow along with the book, the chemical reactions. I'm going to stick my book up here so I can go through it. And the reaction between copper and sulfur has already been done. Okay, so we had copper in our crucible. We covered it with sulfur several times. And then in the chemical formulas lab, you determined its empirical formula. But for this lab here, we want to decide based on how the copper sulfide reacts, whether it's copper 1 sulfide or copper 2 sulfide. So copper 1 sulfide reacts with ammonia. So what we're going to do is we're going to take some of our copper sulfide from this crucible, we're going to add it to a test tube, and then we're going to add some 6 molar ammonium hydroxide, or ammonia. Those are the same things. And if it reacts and turns into a blue solution, we will know that what we made in the chemical formulas lab was copper 1 sulfide. If this copper sulfide stuff does not react and it just sits there in the solution of ammonia, we'll know that the copper sulfide is the copper 2 sulfide compound. So I'm just going to use a spatula to kind of break this up. So there's a couple of questions you want to think about. Does this resemble copper? Remember, copper is kind of shiny. It was in ringlets. Okay, does this resemble copper? Is it possible to bend this without breaking it? I don't really want to stick my fingers in there, but if I just use my spatula here, you'll see that when I do it, it breaks. Okay, it breaks pretty good, breaks up. It is not flexible like you would think that copper wire would be. The next question that you're going to fill out on your report sheet is, what color is it? Okay, so there's some black in there. There's some kind of brownish stuff in there, and you can clearly tell if you think about what copper looks like. It's shiny, so you want to think about, is there a reaction that has happened between copper and sulfur to give us this stuff? Okay, this. So that answers questions 1 through 4. Now we want to see whether our copper sulfide compound in here will react with ammonia or not. Okay. Remember, we're thinking about the reaction between copper and sulfur. You see that when I added it, it's definitely turning blue. Okay, so we had that blackish, brownish, solid stuff at the bottom. Now we have a blue solution. Okay, a blue solution. And you can tell that our ammonia was not blue. It's clear. It's colorless in our little dropper bottle. Okay, so thinking about the questions that you need to answer. Does this product, this copper sulfide product, react with ammonia? Yes or no? And then number 6, you want to suggest a formula for the stuff that's inside the crucible, this copper sulfide compound. So is this copper sulfide copper 1 sulfide or copper 2 sulfide? And then number 7 is to write the reaction. between copper and sulfur to make whatever this copper sulfide compound is. Okay, you are not going to write anything that involves ammonia. We just use the ammonia to tell us whether or not this was copper 1 sulfide or copper 2 sulfide. Remember that copper 2 sulfide will not react with the ammonia. It will just stay in the bottom of the test tube. We'd have a clear solution above it. And copper 1 sulfide does react with ammonia. Okay, we are moving on to oxidation reduction reactions. So what you're looking for here is to decide if you have some active metals or non-active metals, non-reactive. So some metals are going to react with hydrochloric acid, HCl, to liberate or to make hydrogen gas. That will be an active metal. Unreactive metals will not react with hydrochloric acid to create any hydrogen gas. So we're going to look at zinc and copper and how they react or not react with hydrochloric acid. Okay, so this is zinc and hydrochloric acid. You can see that it's bubbling here. So it is making that hydrogen gas. So reactive metals will react with acids to create a metal salt. So in this case, that metal salt is going to be zinc chloride, ZnCl2, zinc chloride, and it's liberating hydrogen gas. So those bubbles that you see are hydrogen gas being released. Okay, so this is an active metal. It's definitely active. It's definitely reacting in there. And you can make your observations. Okay, so it appears that nothing is happening. And number 11 asks, is copper an active metal or an inactive metal? So just to compare the two that we looked at, we have on the left, we have that copper and hydrochloric acid, and on the right, we have the zinc and hydrochloric acid. So zinc is very active. We can see that bubbling still happening. That reaction still going on, and still nothing happening in the test tube with hydrochloric acid and copper. Also, you want to know about unreactive metals. They might react with nitric acid. Okay, and then in the next video, we're going to look, or the next part, we're going to look at the reaction with copper and nitric acid. Okay, and if you do have an unreactive metal that reacts with nitric acid, it's going to make some kind of oxide gas, some nitrogen oxide gas. Okay, so we'll look at that reaction in a minute. The reaction between copper and nitric acid. So I have copper in my little container here. I'm going to use just one piece of it, and I'm going to put it in my test tube. Okay. So I have that piece of copper in the test tube, and I also have concentrated nitric acid. Again, we're handling all these chemicals inside the hoods today. Especially for this reaction, you do not want to breathe in any of these gases that might be made. You want to keep this inside the hood, but you can see that there's some liquid, a solution on the bottom, and there's also some gas coming out of that test tube. To hold this test tube, it is getting warm, so this reaction is releasing some heat. It also made that brown gas. Okay, so think about those observations there. We are not going to observe the odor of this because this gas is actually toxic, so we don't want to breathe it in. Another reason why we're doing this inside the hood. But you need to be able to identify what this gas is. So looking at its color, knowing that it has a pungent, toxic odor to it, because I'm telling you that, you can use the table that is on page 58 to identify what gas comes off of this reaction. So number 14 says to suggest a formula for the gas. So again, using page 58, identify what that gas is. And then so here I'm just adding some distilled water to this so we can look at the solution, the other product that was made in this reaction between copper and nitric acid. Okay, so we have a blue solution, a light blue solution. So you want to be able to identify what this solution is, again, using that table on page 58. When you're trying to identify the products, you can use the table on page 58. You also want to think about what your reactants were. Okay, so we couldn't have made anything, we couldn't have made copper 2 sulfate. Copper 2 sulfate is also a blue solution. It might look kind of similar to this, but we started with copper and nitric acid. There's no way we could magically form copper 2 sulfate. There's no sulfate in here to begin with, okay? So you want to keep that in mind when you're trying to identify your products. But this solution is light blue. It's going to be under the water-soluble solids. That's going to be our product. So all those water-soluble solids are aqueous. That's their physical state. And it looks like there's only one that's blue, so you should be able to identify what is in our test tube here.